Welcome to the product training module for the new Bourns IsoMOV hybrid protector. This is an exciting new technology developed by Bourns for our circuit protection industry. In this module, we'll introduce this technology, give you some idea of how it's put together, and describe some of the distinct advantages it has over existing technologies. The first item on the training agenda will be to review the construction of the Bourns GMOV hybrid protector. The GMOV protector is the predecessor product, and it's important to distinguish the GMOV component from the IsoMOV component. The IsoMOV technology overview will explore the IsoMOV component advantages. We'll discuss the IsoMOV device ratings versus some of the benchmarks. Plus, we'll look at the end-of-life failure comparison. And then finally, we'll summarize the advantages of the IsoMOV hybrid protection component over competing technologies in the industry. A few years ago, Bourns released the GMOV hybrid protection component. The GMOV device is a combination of our Model 2017 GDT with flat technology, which is a revolutionary product in and of itself, soldered to a Bourns MOV disc. Now that series combination of a metal oxide varistor, or MOV, and a gas discharge tube, or GDT, has some advantages in the marketplace, and we'll get into some of those. But this was a simple combination of existing technologies, a GDT married to the appropriate MOV. The IsoMOV hybrid protection component takes that integration to the next level and actually creates GDT functionality between two MOV discs. Each of these MOV discs has half the voltage rating of a GMOV component MOV, so that the combined voltage of the two IsoMOV MOVs equals the MOV voltage in the GMOV device. The space in between the two MOVs in the IsoMOV device has the same functionality as the GDT in the GMOV device. So as you can see, this is quite a bit more compact in its design, and it turns out it has a few other advantages as well. It's a much simpler device to manufacture. It's got a lot fewer components, and that makes it a more reliable part, a more robust part. In the first photo on the left, you can see some of the subassembly parts. These are MOV discs that have the green glass seal material applied to them, and the emissive coating material applied to the waffle pattern in the center. In the manufacturing process, we take two of these discs and seal them together. It's important to note that the glass has two roles. It provides the seal around the GDT, and it insulates the two MOV discs from each other to ensure that the current goes through the GDT. The second picture shows a finished IsoMOV device that has been intentionally broken apart. You can see the blue epoxy coating on the outside, followed by the black MOV material, followed by the green glass, and then the GDT area in the center. The diagram at the lower left shows a suggested new schematic symbol to represent this hybrid device. There is no accepted symbol for this in the industry, so we're just suggesting this as a possibility. Now that you understand a bit about the construction, let me call your attention to the IsoMOV logo shown in the upper right image. Now what is really kind of cool about the IsoMOV logo is that there's a GDT symbol that's actually inside the MOV, and that's really the story here. With the IsoMOV protector, we put the GDT inside the MOV. And once this sandwich is put together, the manufacturing process is just like an ordinary MOV. We attach the leads and add the blue epoxy and print the part number on it. The next few slides list advantages the IsoMOV component design has over conventional MOV products. Some of these advantages are also found in the GMOV component. Some others are found in a discrete series combination of a GDT and an MOV on a circuit board. In each of these designs, there is a symbiotic relationship between the MOV and the GDT that enhances the reliability of the performance of the overall device. The MOV and GDT support each other. Both elements are designed to sustain the maximum continuous operating voltage so that if the other element fails for any reason, you still have a line voltage rated part that will continue to protect the load. What's really useful in the relationship between the two is that the GDT blocks any leakage currents that would normally be flowing through the MOV, drastically reducing the stress on the MOV, which could cause premature aging of the MOV. So the GDT switches off the leakage current through the MOV, which eliminates a key source of the aging. The MOV returns the favor by preventing the follow-on current that would flow from the power line through the GDT after a lightning surge. If the MOV were not there, the GDT would quickly be destroyed by the power line current after it was triggered on by a surge event. So the MOV's job is to save the GDT. The GDT's job is to save the MOV, and they work together just beautifully over their life. Even after many surges, the GDT still prevents that leakage current, even though the MOV itself may be compromised. And that keeps the MOV from ever getting into the situation where a thermal runaway condition occurs. A normal MOV, towards the end of its life, starts to get more and more leaky, and that additional leakage causes dissipation in the MOV, raising its temperature. The increased temperature further increases the leakage current and leads into a runaway situation. Now that simply does not happen with the IsoMOV hybrid protection component, because the GDT prevents that dangerous leakage current from ever getting started, and hence the temperature never rises. Another aspect of the IsoMOV product design is the unique geometry of the MOV that funnels the current back into the center of the MOV and actually improves the MOV's performance. In fact, it almost doubles the surge capability of the MOV. The gas discharge tube has plenty of surge capability for these ratings. So what you end up with is a component that has a better surge rating than its MOV counterpart of the same size, due to the better distribution in surge energy. Because of the simple construction of this device and the presence of the GDT, we can extend the operating temperature range of normal MOVs. Even when an IsoMOV device is operating at higher temperatures, that increased leakage current that you would normally see in an MOV simply doesn't exist. Another feature of the new IsoMOV family of hybrid protectors is an extended voltage range. We're offering devices with a maximum continuous operating voltage of 555 VAC, which is suitable for 480 VAC line applications. This high voltage capability, coupled with the extended temperature range, make the IsoMOV protector especially well suited to industrial applications. Because the MOV and the GDT are rated to take the line voltage, we don't know exactly what the sharing is going to be between those two, because it's dependent on the aging characteristics of their histories and events. But what we do know is that the actual breakdown voltage of this device is going to be much higher than the breakdown voltage of either device separately, because they do share that voltage to some level. The IsoMOV devices can tolerate AC voltages beyond their maximum continuous operating voltage rating for extended periods of time. Bourns has a technical paper on lab data that compares the IsoMOV protector to competing technologies. It's important to note that while the IsoMOV device will survive these higher voltages, they do not protect against them, and those higher voltages are being passed downstream. The load must be designed to withstand these higher voltages. Unlike many competing technology devices that will disconnect themselves from the line under these conditions, the IsoMOV device will be there after the event, continuing to protect against lightning and switching transients. IsoMOV hybrid protectors are listed as UL 1449 Type 4 component assemblies. If you're an experienced surge protection device designer, you know what that means. You know that's going to make the UL 1449 qualification of your product a lot easier. There's an assortment of tests you're not going to have to do, because you're already walking in with a rated component assembly. That saves SPD designers a lot of time and headaches. And then finally, I want to talk a little bit about how an IsoMOV device is expected to behave at the end of its useful life. In our industry, we know that only a small percentage of protection devices fail in the field. But those failures can be catastrophic. A device of any technology, if you push it hard enough, if you hit it long enough, will eventually fail. Designers often specify MOV devices with higher operating voltage ratings and higher surge ratings than they need in order to reduce the chances of a field failure. Another unique feature of the IsoMOV protector is the primary failure mode, which is quite benevolent when the circuit is fused properly. It's very quiet, it's very simple, and because so little energy is involved, very little smoke is released. In our lab testing, there is no arcing or sparking. All that we see is that it blows the line fuse. We use a 10 amp fuse in our lab, and when you finally beat up the IsoMOV device to where the MOV just really isn't much of an MOV anymore, it still isn't leaky because the GDT is there. Then, finally, you get to a point where the GDT cannot survive without the MOV helping it anymore. Now, when that happens, you basically have shorted out the AC line, and the line fuse blows very quickly and very cleanly. In a few slides, we'll see some short videos to illustrate how that works. There are competitive products out in the field that indicate when the MOV has gone offline due to overheating, so that the maintenance people can come out and replace it. That's not a concern here, because the high leakage failure mode of the MOV, which slowly heats up and activates the thermal disconnect, simply doesn't exist in the IsoMOV component. In an IsoMOV protector typical failure mode, the device suddenly experiences a short and blows the line fuse. So the indication of the failure is the fact that the equipment is no longer working because it has been safely taken offline. So how do we stack up against the competition? Well, we looked at many competitor data sheets as well as data sheets for Bourns MOV products. We focused on the 320-volt AC-rated products, and we looked at 10mm, 14mm, and 20mm products. We compared the nominal surge rating and the maximum product diameter from the datasheets. Notice that the maximum product diameter from the datasheet doesn't really correspond particularly well to the nominal size designation. However, it does give you an idea of the class size of products offered. Another thing to notice is that for a market that many believe is highly commoditized, there's really quite a bit of variation in the ratings of the various product lines. The best-in-class rating for each size is highlighted in blue. When we look at the 10mm products, we find that the best-in-class for nominal surge rating is 2,000 amps. But look at the IsoMOV protector at 3,000 amps. In fact, the 3,000 amp IsoMOV device rating actually matches the best-in-class rating of the 14mm products. And the 14mm IsoMOV protector with a 5,000 amp nominal current rating actually matches the best-in-class of the 20mm nominal MOV products. The 20mm product has an 8,000 amp nominal current rating. By selecting the Bourns IsoMOV hybrid protection component, we've shown that you can not only select a superior product, but you are also choosing a smaller product with the same ratings. This means designers specifying higher voltage rated MOV devices to achieve acceptable design margins may find that a smaller IsoMOV device with lower protection voltages is the right choice. Choosing a higher voltage rated MOV won't be necessary because you've got the MOV and the GDT in series that can tolerate the temporary overvoltage events. Another important benefit to the lower clamping voltage design is the possibility of employing lower voltage rated components downstream. Other designers may have specified a higher surge rated MOV than they thought they might need to ensure longevity. The IsoMOV protector has the added surge capability in a smaller size. Alternatively, a designer may opt for an IsoMOV device in the same size and enjoy a longer service life or higher surge ratings. Designers have many options available to do cost downs, to do size downs, and to generally improve the overall safety and performance of overvoltage protection in their products. Now, let's talk a little bit about end of life. We're now going to compare the IsoMOV device to some benchmark products and show you what they do. In no way are we saying that these components aren't quality products. This is simply a demonstration of how these benchmark products performed in comparison to the IsoMOV device in this laboratory test. The test that we're going to focus on is the application of simulated lightning surges on a live AC line. Now, this is not the way UL 1449 specifies it. UL 1449 specifies applying the surge to the device and then within 1 second applying the AC line voltage. The reason UL specifies the test in this manner is most likely due to an equipment restriction they had when they first started doing these tests. Now equipment is available that allows you to apply the surge while you're on the AC line. As it turns out, surging devices while they are connected to the AC line is quite a bit more stressful for the protectors. But it's also more real-world. Next, we'll demonstrate how these devices fail. And again, none of these failures are necessarily a violation of any certification or any testing or any claim being made. This is merely a demonstration of what we can expect to happen. The first test we'll look at is on the left. The blue part is a 14mm class MOV. This is a quality conventional MOV design from a well-known manufacturer. We're applying its specified rated voltage, and we're going to apply its rated nominal 3000 amp surge. So in the lab, we would do this over and over again until we saw something happen. In this case, the device fails on the 11th surge. It did blow the 10 amp fuse, but this is not necessarily an unsafe failure. As you watch the video, you can draw your own conclusions. Now you saw a little bit of fireworks there, right? The epoxy jacket on the MOV has split and exposed some of the interior parts. Some flame and some smoke was also emitted. And although it was over pretty quickly, is that the best we could do? The second part in the middle is a thermally protected MOV. Again, we're applying the rated voltage to it, and we're applying its rated 3000 amp surge. This time, the failure occurs at the 8th surge. Ready? Here we go. This one failed in a more dramatic fashion. You can see that some of the epoxy coating was broken off and ejected from the part. Now, I would just point out here that the thermal protection that you get in most of these MOVs doesn't really do much for you in a surge event like this, right? That thermal disconnect feature is there to disconnect the MOV if the MOV starts getting hot due to excessive leakage. But the thermal protection does absolutely nothing to stop that leakage before a thermal runaway condition begins to occur. It just allows the MOV to tolerate that leakage current and disconnect itself safely from the line. Actually, disconnection is not guaranteed because UL testing on those thermally protected circuits is done with a restricted current, and testing is not done on a full AC line. It's unclear whether or not the thermal link will successfully disconnect in the real world. Okay, third movie. The one on the right is a Bourns IsoMOV protector. This is a 14mm device as well, and we again apply the maximum continuous operating voltage to the device. The surge we are applying is 4500 amps, 50% larger than the surge applied to the previous devices. We're looking at the 9th hit in the video. Again, the 10 amp fuse blew. Now hopefully you saw that little bit of smoke. Let's go ahead and replay that again so you can take a closer look at that. You can see there is a tiny pinhole in the epoxy where just a little wisp of smoke escaped. The reason it fails so cleanly and so quickly is that after the 8th hit, we were left with an MOV that was just on its last legs. It really was in bad shape, but the gas tube was preventing it from leaking. Had we tested the device, it would have tested just fine. However, on that 9th hit, when the MOV can no longer hold back the GDT's follow-on current, it blows the fuse so quickly that there's no energy release to cause a lot of problems. I hope that was fun for you. So let's review the Bourns IsoMOV protector feature benefits. The table shown here covers 10 things you might want to consider, and you can see the IsoMOV meets all 10 considerations. A conventional MOV meets none of them. A discrete MOV and GDT or a GMOV device covers about half of these. A lot of the thermally protected MOVs carry the UL 1449 Type 4 component assembly listing, so you would get that feature if you were buying that product. You can see, just going down the list, the IsoMOV protector has a space-saving form factor. We talked about how you can achieve the same surge capability on a smaller part. You achieve the ultra-small leakage current, which can help you with Energy Star ratings, and can certainly help with any other leakage current test requirements you might have. The IsoMOV protector has a lower clamping voltage for particular surges because it does a better job of distributing that current across the MOV. It has the isolation built in. It extends the MOV's life because it doesn't continuously age with constant leakage current and constant exposure to the AC line. The IsoMOV protector is more tolerant of temporary overvoltages than conventional MOVs or thermally protected MOVs. It has state-of-the-art surge ratings. It has higher temperature ratings and a graceful primary failure mode. There's no need for expensive failure indication circuitry, and it comes with the UL 1449 Type 4 rating. Thank you for your attention. I hope you're now as excited about this product as we are. We look forward to releasing a host of other new products too. Thanks again for your time today.